you not in class today, this was the bell work that we did. You don't have to do it if you were excused absence, but you need to know these words, especially the word of adjacent. Adjacent means two angles that share the same side. So like PWK and KWH are adjacent angles. Hello, Orca Dorks. That would be David. On problems 8 through 10 on 5-4, all you had to do is you had to write a congruent statement. A congruent statement, if you remember right, would be something like triangle ABC is congruent to triangle KLM. That's a congruent statement. I should put a triangle right there. Okay. It says name the pattern that you use. That would be something like side angle side, or side side side, or angle side angle, or the other one is angle angle side. Those are the four that you could use for naming your congruence pattern. And then it said to connect lines to them. Like if you have a triangle like this, and all you did is I'm going to duplicate this so it works better. Clone it. Where is that? If all you did is did a translation like that, and you connected corresponding vertices together like this, and in a translation, what did we learn about those corresponding vertices? I mean, if we connected the corresponding vertices, what did we learn about all the lines that it made? Yeah, they should be parallel, and so that's what it's looking at on the translations. Okay? So on a rotation, what did we learn about rotations? It's 180 degrees. If you rotate it 180 degrees, we also learned that they're parallel too, right? Just connect them and see. 5.3 is due today, but I'll let you ask me a question or two on it if you got a couple more that you have. Okay, Maddie. Okay, on 14, is that the one where had the I know statements? Yeah. Okay. Which one are you confused on? All of it? On what to do? Okay, well, it has all those I know statements at the top, right? Can I borrow this right here, Thomas? Okay, it has some I know statements, and you are supposed to transfer them down to that box on the bottom, that table on the bottom. Notice that the first it did for you already. It gave, number one was that the quadrilateral ADEG is a rectangle. That gave you that information up in that starting paragraph. It also, number two says segment ED bisects segment BC. And that's the first I know statement. And that was given to us, right? Now, you're going to go down to the next one. The next one is I know that segment BE is congruent to segment EC by definition. And so you're going to write that down in there. You're going to write BE, segment BE is congruent to EC in the left column. Do you see that? And in the right column, you're going to write the reason, which is the definition of bisector, or because of the definition of bisector. Like on the third I know statement, it says that GE must be parallel to AD, so that's your statement. GE is parallel to AD, and so you're going to write it like this. GE, and you're going to use the symbol as parallel to segment AD. That's your statement that's on the left column. And your right column is going to be because we know that opposite sides in a rectangle are parallel. That's the reason. Opposite sides of a rectangle are parallel. Okay, because you can even say definition of a parallelogram, because a rectangle is a parallelogram, and we got it that way. So that's kind of what you're doing on those I know statements. Okay, the fourth one down, I know that segment GA is parallel to segment ED because they are opposite sides in a rectangle. It's the same thing right here, except for they wrote it with the symbol in between. But you write the reason on the left and the statement on the right. Now, I think on that one, I think it's the 1, 2, 3, 4, 5, the fifth statement down, the fifth I statement down, it says, I know that segment AD is contained in segment AC so that AC is also parallel to GE. I would actually put the right side of that as the reason. AC is parallel to GE, and then I would write the reason is that AD is contained in AC. That's what I would do. I would write it that way. Does that make sense? So the statement's at the end, and the reason is at the first. And so you're going to go all the way down until you have written all those I know statements down in symbolic notation. Okay? Any other questions on 5.3? On your quiz that we're going to have on Thursday, it will cover everything in sections 5.1 through 5.4. Did I hand back some of your assignments yet? I think I handed back 5.1. I'll hand back 5.2 and I'll record 5.3 today and hand that one back to you. And then 5.4 you'll have still, so you can study that. And then we'll take the quiz on Thursday. We are going to have lesson 5.5 today, though. Okay. Okay, you guys, today we're going to talk, this is Module 5, so get out your notes. Module 5.5, sorry. Module 5.5, we get to talk about certain angles. Hey, these 4 definitions, need to know them for the next test that we will have. Yeah, you guys, this is not a lesson I made, so that's why, whoops, I'm going to leave that there. This one actually, Mr. How's that? Is that better? This is the student teacher for Mr. Prince has made this one. So I sometimes write things too small. You learn after a little while how to make them bigger. Vertical angles. Okay? Angles. Opposite one another when 2 lines intersect. You guys, this line right here is called a transversal. Okay, this line right here is called a transversal. A transversal is a line that intersects more than one line. Okay, usually when we talk about transversal, we're talking about a line that intersects 2 lines. Okay, so you can write that definition down. A line intersecting two other lines. It should be really 2 or more lines, but we usually do 2 lines. Okay? So that line right there is called a transversal. Any line that intersects 2 or more lines is called a transversal.
Do the 2 lines have to be parallel?
No, they don't have to be parallel, but we are going to study the properties when they are parallel. Okay? And that's what you're going to learn about today. So, good question. Okay, now, right here, the vertical angles are angles opposite one another. So, which angles are opposite from one another when 2 lines intersect? Give me an example. 1 and 4 is an example of vertical angles right here. So that's it. Where else? 5 and 8. Where else? 6 and 7. Where else? 2 and 3 are examples of vertical angles. So just so you have it in your notes, I would put like angle 1 and angle 4 is an example. You don't have to put all the examples, but angle 1 and angle 4 would be an example. Okay? Christian, we're just starting the notes for lesson 5.5, so. Okay, alternate interior angles. We usually abbreviate these as AIA, alternate interior angles. By the way, oh yeah, you guys aren't taking it. When you take the ACT test, there's always questions to do with what we're talking about today on the test. Okay? So if you know this stuff, and this is easy stuff, and this is stuff you're going to use when you get in algebra and trigonometry, especially trigonometry, you'll be using this kind of information, and it's really easy, but you need to know it. Hello. Alternate interior angles. Let me give you an example of those. Okay, the definition of alternate interior angles would be angles. I should say a pair of angles, but we'll just say angles. Angles inside the two lines meaning these two lines right here. This one and these two right here, okay? Inside the two lines, opposite sides of the transversal. Yep. Let me talk about that in just a second. Opposite sides of the transversal, that was already asked, but I'll answer it again. Opposite sides of the transversal and opposite intersections. This is kind of a long definition. It's more of a description of where they would be, but if given that description, which pair of angles do you think would be alternate interior? 5 and 4, what else? 3 and 6. Those are called alternate interior. So an example, if you want to write these down for alternate interior, would be angle 5 and angle 4. Okay, yeah, so they're in between these two lines. They're on opposite sides of the transversal, so one on the left, one on the right, and opposite intersections, so one on the top one on the bottom one. So 3 and 6 or 4 and 5, okay? They're alternating interior. That's cool, huh? Alternating interior angles. Okay, that's alternate interior angles. Corresponding angles. Corresponding angles. Let me show you that definition right here. I'm going to move this up. Corresponding angles. That's this word right here. I should fix this and write more room. But all corresponding angles would be two angles in the same spot, different intersections, right? Two angles in the same, I don't know if that's, spot's not a very good word. Two angles in the same location, different intersections. Good word. Different intersections. Okay, so what would you think would be a pair of corresponding angles? Say it again. 1 and 5, okay? So 1 and 5 would be corresponding, so angle 1 and angle 5. How many pairs of corresponding angles are there? There are 4. What are some others? 4 and 8 would work. Angle 4 and angle 8. What else? 3 and 7, and what else? 2 and 6, okay? So those are examples of corresponding angles. Okay, so it's kind of like living on the northwest corner of a block, and then someone down the street on the next intersection is on their northwest corner of their intersection. The next house down is on their northwest side of their intersection, and so forth. Okay, so that's an example of corresponding angles. Now, think about the phrase same side interior angles. That's pretty self-explanatory. Which ones do you guys think are same side interior? 3 and 5. What else? Angle 3 and angle 5. What else? 4 and 6. Angle 4 and angle 6 are examples of, well, because same side interior is pretty descriptive, isn't it? Do you guys understand that? I'm not going to give a definition of same side interior angles because that's a pretty descriptive name. If it's inside, it's interior, it's between the two lines. Same side, that means the same side of the transversal. So 4 and 6 would be a pair, 3 and 5 would be a pair. Any questions there? Okay. Next word right here. Remote interior angles. Okay. What does the word remote mean? Well, what's a remote control device that you use for your TV? What does it do? It controls your TV from far away. Okay? When I was growing up, we had remotes too. Your dad would tell you, I was the remote in my family. My dad would say, go over and change it to channel 5. So I'd go down, go up and turn up the volume. Can you believe that? We did. So remote means away from, right? Okay. So and exterior angles. We're going to talk about which angle is exterior to this triangle. Okay, angle 4 is an exterior angle. Okay. Now, which ones are remote to angle 4, but interior? 2 and 1. Okay. So angle 1 and angle 2 are interior. Oh, angle 1 and angle 2 are interior and remote from angle 4. So angle 2 and 1 are the remote interior angles of angle 4. How do you make an exterior angle? How would I make an exterior angle over here by angle 1? What would I do? Okay, yeah, extend the side out. And this angle 5 would be an exterior angle. I could also extend this side out. We could call this angle 6, and that would be an exterior angle. Now, I could call this angle 7 right here, but we consider it an exterior angle, but we don't consider it to have remote interior angles. Okay, so when we're talking about exterior angles of a triangle, and we should have really written this, exterior angles of a triangle. Angle 7 is not an exterior angle of a triangle. Okay? Angle 7 is not considered an exterior angle of a triangle. By the way, well, we'll talk about that in just a sec. So everybody understand the definition of remote interior angles and exterior angles of a triangle? Any questions there? Okay, next, right here. Okay, we are going to do a little activity right here. We're going to follow these instructions. I forgot to mention this, so this was the conjecture we made about vertical angles. We already talked about it in class. This is for everybody who's listening to this at home. Vertical angles are congruent. So if this angle over here is 38 degrees, x is 38 degrees. Then we did a proof of vertical angles. Someone can study through that if they want. And we're right here. Okay, so what I was saying, you guys, is that any line cutting through two other lines, is a transversal. However, if the lines are parallel, like I'm showing right here with the red arrows, then the lines have special properties. And we already talked about vertical angles being congruent. So we know what are what are two angles that we know are the same? Measure. 1 and 4, 2 and 3, 6 and 7, 5 and 8. Okay, so because of vertical angles. Now we're going to learn some others that are congruent. Okay, so angle side angle. Alternate interior angles. Sorry, alternate interior angles. I told you we'd abbreviate that as AIA. Alternate interior angles. Let's look at angle 3 and angle 6 right here. There's a pair of alternate interior angles. Okay, you will notice that since these lines are parallel right here, we know that angle 3 and angle 4 add up to 180, right? We also know that angle 5 and angle 6 add up to 180, correct? Okay. Now, And that's going to be the case whether those two lines are parallel or not. Now, since they're parallel right here, doesn't it make sense that this line cutting through them is going to cut through at the same angle? Okay, and notice that angle 3 and 6, do you think those are supplementary or congruent? Are they both acute or are both obtuse angles? Or is one obtuse and one acute? They're both acute angles. So, do you think they're congruent? Yeah. We could do a proof of this, but we're kind of getting out of time, so So, also, 4 and 5 are both obtuse, and they're congruent. So, what you need to know is alternate interior angles are congruent when the lines cut by the transversal are parallel. Okay? Write that one down in your notes. Alternate interior angles are congruent when the lines cut by the transversal are parallel. What do you think about same side interior? We usually don't abbreviate them as SSI, but I'm going to. Same side interior angles. What do you think? What's the pair of same side interior angles? Okay, so we just learned that angles 3 and 5, same side interior, or angles 4 and 6 are going to be supplementary. Same side interior angles are supplementary. Under what condition? When lines are parallel. Okay? So we know that isn't much information. Okay, let's talk about the last one, corresponding angles. CA, corresponding angles. What do you think about corresponding angles? Like 4 and 8. Angle 4 and angle 8. Think they're congruent? If you think about this, you guys, 4 and 8 are congruent because they're in the same spot in different intersections, but since those lines are parallel, this line's cutting through them at the same angle. So 4 and 4 and 8 are congruent. So corresponding angles are congruent when lines are parallel. I'm going to put the parallel mark. Okay, when lines are parallel. So alternate interior angles and complementary angles are congruent. Same side interior angles are supplementary. Everybody got that down? And vertical angles are congruent. You have to memorize all these. You got to know them. These are things you just have to know. This is kind of intuitive, you guys, if you think about it. You can tell if you're having trouble looking at something and telling whether they're congruent or not. If you know those two lines are parallel, look at them and just say, what does my intuition tell me about them? Are they supplementary or are they congruent? Most books teach about exterior angles, and I don't know why this one's not, but C7 and 2, these are called alternate exterior angles. What do you think they are? Congruent. How about 1 and 8? Congruent. Okay, so those are called alternate exterior angles. Okay, everybody in your group right here, I want you to look at this picture right here. What do we know about if we have a triangle, what do we know about the three angles of a triangle? Okay, the three angles of a triangle add up to 180. Three angles of a triangle sum to 180 degrees. We know that already, right? How could we use that to help us to find the sum of a quadrilateral, the four angles of a quadrilateral? Split it into triangles. How? How many is the least number of lines I can draw to make this into all triangles? Some say it's 2. Anybody think I can do it with 1? Roger, how would I do it? Okay, yeah. If you go to any vertex to any vertex and you cut it in half like that, you get 2 triangles, right? I could do it the other way. I could do it either way. Okay? We could do it either way. We could do it this way.
Oh, erased it. Well, there you go. Or
We could do it like that.
like this.
Now, how would that help me? How would that help me show what the measure of the 4 angles of quadrilateral are? Let me ask you this. What do these 3 angles of this triangle add up to? 180 degrees. What do these 3 angles of this triangle add up to? 180. Now, if you think about it, this angle plus this angle makes this top one by the 16x plus 15, and this angle plus this angle makes the one down by the 7x minus 3, right? What's 180 plus 180? What do you think the 4 angles of quadrilateral add up to? 360. Okay? That's actually, we could write a formal proof using that, by the way. Okay, but that's how they go about writing proofs for that, is since they know already that the angles of a triangle add up to 180, we could do a proof that way. So, knowing that information in your groups right now, so everybody write this down in your notes. The 4 angles of a quadrilateral sum to 360 degrees. Okay, I'm going to give you guys 2 minutes in your group to find the measure of each one of these 4 angles. Go. Okay, so most of you guys knew that you just had to add the 4 angles together. 7x minus 3 plus 4x plus 23 plus 16x plus 15 plus 6x minus 5 equals 360. When you simplified the left side, you got 33x plus 30. Is that right? You solved the equation. You got x equals 10. So you plug 10 in for each of those. 7 times 10 is 70. Minus 3 is 67 degrees. 4 times 10 is 40. Plus 23 is 63 degrees. 10 times 16 is 160, 175 degrees. 60 minus 5 is 55 degrees. Did anybody check to see if those add up to 180? Good job. All right. Good job. Okay, last thing. Graph that line really quickly. Okay, so you guys all graphed that line right there. The y-intercept was 2. The slope was up 3, over 1, 2, 3, 4. Down 3 to the left, 1, 2, 3, 4. And so you got your line right here. Okay, now, what do we know about parallel lines? Okay, they don't cross. What do we know about the slopes of parallel lines?
They're the same, but the x-intercept is different.
Okay, I want everybody to write an equation of a line that's parallel to this one. But it's not the same line. Go ahead, go. Okay, Branson, give me yours. Okay, so all he did is he changed the y-intercept. Same slope. Therefore, we get 2 lines that are parallel. Any questions on that? Okay, now, you guys, I didn't put every paper of your assignment in here today. This is one page that's not on there, so everybody get out a piece of paper. You're going to attach this to your assignment. It says, parallel lines of the transversal, vertical angles and exterior angles of a triangle, okay? Label, actually, you know what? Let's just do this together. I won't make you turn this in. Label each picture as showing parallel lines of the transversal, vertical angles, or an exterior angle of a triangle. Hey, everybody sit down. No. Sit down. Okay? I didn't say get up. Sit down and listen. Label each picture as showing parallel lines of the transversal, vertical angles, or an exterior angle of a triangle. Highlight the geometric feature you identified. Can you find all three features? So I want, in your groups, I want you to see if there's one that has all three features. That's what I want to do right now. And then I'm going to roll the die, and one group's going to come up and show us. Okay? So go. Okay, group 4 is going to show us.
Okay, here's our little transversal right there. There's two parallel lines.
Okay, so he's saying the fence one has these two, you guys please listen. He said these two are parallel. Any one of these fence posts is the line going through is a transversal, right? Okay. Do you see the exterior angle thing on it?
Exterior.
There is one right there. Okay. People at home can't see this. For some reason, I don't know why I can't write on this anymore, you guys. The thing disappeared. It's a problem. It's a software problem. We called them up, and they don't know why it's doing that. But so exterior angles. What about vertical angles? Do you see vertical angles?
One of these,
Yeah. Yeah, anywhere where two fence posts go through. Okay. Good job. Okay. So you guys are out of it. So now it's 1, 2, 3, 4, 5, 6. 6. That's you guys. You guys are up. Come show us one.
We're 7.
So number 12 doesn't really have, it has a triangle, but it doesn't have any parallel lines. What's another one? 15? I think 15 is a good one because look, thanks, Brennan. If you counted these two lines as the parallel lines, and that's the transversal going through it, also, if you use these white ones as the triangles, anywhere where it extends out further, there's an exterior angle right there. Okay? And vertical angles. It has vertical angles. Okay? All right, your assignment. Okay, test next time. Quiz next time. Be ready for it.